All right, so today we're going to be taking a look at the coin change problem, hopefully develop a solution. So what is this problem? The problem is that you are given M types of coins and you have an infinite number of these coins. You're never going to run out. And you want to make a certain amount of change using this set of coins. And so that's the problem in a nutshell. There's some examples here on HackerRank, which might be useful. So this is going to be the format of our input here. First on the first line, we're going to put the total change that we want to make. So in this case, it's 10 cents. And then we're going to put a space, and then we're going to say we're going to have 4 different coins in our set. That's what that 4 is. And the next line, we're going to give the value of each coin. So in this case, 2536. So we're saying how many ways are there to make 10 cents using coins of value 2, 5, 3, and 6? And the answer turns out to be 5. There are 5 different ways. They go on to show you those ways here. Sometimes those are called witnesses. We don't need those though. We don't need those in our solution. We just need to print 5 as our answer. So that should about cover it. These constraints might be important. We might want to make use of some certain data types. Like longs instead of ints, if that becomes an issue. But let's get started writing some code. All right, so we are in IntelliJ now. We've got our Java class called solution.java and the boilerplate provided by HackerRank. I'm gonna make some slight modifications here that I think make the code more readable and understandable for someone who's not like a professional mathematician. With all these N's and M's floating around, I don't think it makes much sense. So this N is actually our goal. We'll call that goal. That's the goal amount we want to get. M is the, we can leave that M. That's just the length of our coin array. That's the number of different coins, right? C is our coins. That's our array of coins. We're gonna need to change it here to getways goal and coins. So as you can see, we need to fill out this getways function, and then everything should work. They took care of all the reading of the input and everything, as long as you pass it in the way that they want. Up here, let's rename it to long goal and long array of coins. Okay, so what do we want to do first? Let's go ahead and get started on the getways function. I'm gonna go ahead and create the solutions table because we're gonna be using dynamic programming to solve this problem. Basically what that means is that we're gonna solve the problem from the bottom up, whereas a recursive solution would, in this case, it would be doing a lot of duplicate work. We won't go too deeply into that, but basically the most optimal way to solve this problem is to solve it from the bottom up so that you don't duplicate solutions. There are kind of 2 main attacks when you're doing a dynamic programming approach. One is, like I just said, from a bottom up, or you can do top down and memoize. Memoize just means like save your work. Make a little lookup table and you say, hey, have I completed this before? If so, use that answer that I already know. That's slightly more intelligent, a little more overhead usually when you're doing memoization. In my experience, the bottom-up solution hurts my brain a little more, but it tends to be optimal and doesn't have the overhead of like a lookup table. Since we're going to be doing dynamic programming from the bottom up, we need a table to hold our solutions. This table is going to hold, so it's going to be, it's an array, as you can see, of long values, and it's indexed on goal amounts. So at index 5 will be the solution for how many ways there are to make the value 5 with a given coin array. So what do we want the length of this array to be? We want it to be goal, and we're actually going to add 1, and it doesn't like that it's long, so we're going to cast it to an int. The +1 is a little tricky. It's just because think about how many ways are there to make the value 0 with any set of coins. The answer is 1. There's 1 way. You don't take any coins. So we have to account for that case. So we're adding 1. That's going to be our 0 case. So now we have our table. Well, in fact, actually, we need to explicitly put that into our table, that the solution at 0, no matter what array of coins we have, is 1. There's one way to make a value 0. I don't think it's going to like that. That might not be necessary, but I'm going to do it anyway. I'm going to cast that to a long, because that array holds longs. And so now we're going to want to build up our solutions table. I happen to know, oh my goodness, that this is going to require nested for loops. So first, since we're doing this from the bottom up, building up the solutions table, not duplicating any work, we're going to say that first we're going to want to examine each coin in the array. That's going to be important to take into consideration each coin. So we're going to say for int I equals 0, while I is less than coins.length, increment I. That's just the standard for loop syntax for looking at every coin. It's going to give us the index of every coin in the array. And then this one's a little bit trickier. We're going to inside that for loop. So for each coin, then for each desired value, so for each sum of coins that is greater than the current coin we're looking at, which would be this I here. So for every j, which is a total value, for every j that is greater than the current coin value and less than or equal to our goal value, we're going to look at all those. We're going to build it from the bottom up. So we're going to say for int j, actually it's not going to be 0. That was silly. I just said it's going to be the coin we're currently looking at, and that doesn't like the fact that it's long, so we'll cast to an int. So starting at the value of the current coin, while j is less than or equal to goal, like we just said, increment j. What do we want to do? This is the meat of it. So we know that we're going to be doing something with our solutions table, right? And we're going to be setting it equal to something, setting the solutions table at index j equal to something. In fact, so the number of ways to make this sum, in fact, we're not going to want to assign it actually, we're going to want to increment it. We're going to want to increment the number of ways to make this sum we're currently looking at, j, by so we take, it's equal to the number of ways we currently know of, plus the number of ways to make the sum minus this coin. So that's kind of weird to say it. So in other words, if we assumed that we got to this value j by choosing this coin I, then all we have to do is increment the number of ways to make this value j by the number of ways that we already know of, the number of ways to create the value before we chose this coin. So j minus I. In fact, that's exactly what it's going to look like, I think. So plus the number of ways that we currently know of if we didn't choose this coin. I know I'm going to have to cast it to an int, learn my lesson there. Coins of I. And is that, yeah. So, okay. And I think that's all there is to it, actually. I think what I'll do, well, we need to return solutions table of goal. Oh, yeah. Another data type issue. We'll cast it to an int. The reason that I'm using longs is because I happen to know that in HackerRank the values get so large that they're going to overflow the int data type. So certain things just have to be longs. But when you're accessing an array by index like this, that has to be an int. So we have to do an explicit cast there. I think what we'll do, because I'm not sure that I did a very good job of explaining exactly how that works, is go ahead and write like a pretty print function that's going to print out all of the different steps of the table, and we can walk through that and you can have a better visualization of that. All right, so we've got the print lines in there now. Notice that it's inside the nested for loops. It's going to print out for every single iteration in here. Maybe the best way to show this is just go ahead and run it, and then we'll see what's going on. So let's go ahead and run this code. And it's going to sit there and wait for us to put in some input. So let's pretend that we want to make the value 11 with 3 different coins. And our coins are going to use 2, 3, and 4. And so now you can see it printed out all the steps that I went through to build the solutions table, the array that we called solutions table, so we can get a sense of what's going on here. So we can see the current coin and these visible steps is 2. So for this first step, it's saying for the coin of 2 and for the goal of 2, we're going to build up our goal to 11 eventually, our ultimate goal. We're building from the bottom up, remember, dynamic programming. So we're saying how many ways are there to get to a goal of 2 with a coin of 2? Well, there's one way. You take a coin of 2, so we put a 1 there. To get to a goal of 3, well, there's no way to make 3 with a 2 coin. 1 gets you a goal of 2. 2 coins gets you a goal of 4. You can't hit 3, so we leave that at 0. To get 4, though, we can make 4. We can select 2 coins of 2, and how we got that number is we said add to this 0, because this was a 0 before we added to it. Add to this 0 this 1, because we can get to 2 from, we can get to 4 from this 2 using a coin of 2. So add it there, blammo. Hopefully that kind of gives you a sense of what's going on. It's going to iterate through all of the goals up to 11 for a coin of 2, and you can kind of imagine what that looks like. Probably it's just going to be all the even numbers. Let's get to the goal of 11. So you can see here all the even numbers: 0, 2, 4, 6, 8, 10. Those are all added. That's what you can make with the coin of 2. Now that our coin's 3 and our goal is 3, you can see we filled in the 3 here because you can make 3, and it just continues on like that. Noticing we'll start to get some 2s in here because we're incrementing. Where is it happening? Plus equals, right? We're incrementing what we already know to be true with other states, and eventually we get down to the last step. In this case, it's step 26, and we notice that there are 4 ways to make 11. So that's our answer. There's 4 different ways. If you have a question, leave it as a comment. I'll do my best to answer it. Also, if you have any problems you'd like to see explained in future videos, add a comment. Otherwise, thanks for watching.